Hello everybody, my name is Walter and this is episode 67 of my Redstone Commands Series. This is also one of multiple episodes in which I want to cover how you can implement more advanced mathematical functions that are not directly available through the scoreboard command itself. Now in this episode I want to give you an example of reusing existing game mechanics to implement, in this case, a sine function. So the idea here is pretty simple. The game already implements lots of mathematical functions as part of the basic game behavior. For example, trigonometrical functions are involved when it comes to the rotation and the translation of entities, which, since we have access to the rotation values and the position values as part of the NBT data, allows us to reuse that behavior for ourselves. So let's say we have a rectangular triangle. One of its angles is alpha, and the long side has a length of 1. That means that the short sides are the sine of alpha and the cosine of alpha. Now, if we take an entity and rotate it by alpha and move it one block forward, then if we take the original position and the new position, we can calculate the sine of alpha and the cosine of alpha by simply taking the difference of the corresponding coordinates. And that is exactly what I have done in this example here. So I have two functions. The first is just initialization and final cleanup. And the second is where the actual implementation of, in this case, a sine function happens. So let's quickly go through this. Now I decided to go with macros for this, so the alpha value is given as an argument during the function call. You can also use, for example, something like a scoreboard objective with the scoreboard command. But let's go through this. And little side note here, I'm using the trick from the previous episode, so episode 66, where I showed how you can emulate fixed point operations using scoreboard objectives. If you haven't watched that episode, I would recommend to do this first, or you might get a bit confused. Now with that out of the way, let's get started. So the first thing we need is a scoreboard objective to work with. Once we have that, we can summon in our entity, and that is done in a very specific way. So I'm summoning in at my own position, but then I'm aligning to XYZ. I'm aligning because otherwise you might get rounding errors concerning the last digit of your values depending on where you are. So for a consistent and correct calculation, you have to align to the coordinate grid. After that, I'm just running the summon command for an area effect cloud. I'm using an area effect cloud because, to my knowledge, it has the least overhead of all entities, and it also has an inbuilt dev timer or timeout. And if anything goes wrong in the following, it will still delete itself, and I don't have to worry about creating entities in the world that remain and produce lag. I'm obviously summoning it in this specific position, and then I'm giving it some NBT data. First of all, I'm setting the duration, so the timeout, to 1 game tick. Then I'm setting the rotation of this to alpha. Now, if you're not using macros, you would have to split this off into another command, for example, an execute store command, where you're writing the value directly into the rotation value of the entity once it's there. And then finally, I'm giving it a tag, temp entity in this case, to be able to directly address this area effect cloud in the following. Once we have that, we can call the second function as the area effect cloud and add the position of that area effect cloud. The function call itself is pretty straightforward and nothing really fancy going on. Once we have calculated the sine, I'm getting rid of the area effect cloud again. And then you could, for example, delete the objectives or do anything else. In this case, I'm just setting the display on the side so we can see the various values. Now let's have a quick look at the second function. And this is where the sine is actually implemented. So this is pretty straightforward. So the first step is storing the x value of the original position as temp1. Then, and remember, the entity is already rotated correctly, we teleport 1 block forward. Then we store the new x position, or x value, in temp2. Then we calculate the difference of the two. And then finally return that result value. And that's already the entire magic, so let's have a look at this in action. So let's start with the sign of 0, and as you can see, normal function call, but with the macro argument alpha 0. And on the right side here, you can see in the display, we have the temp1 is -9, temp2 is also -9, so the result is 0. And if I were to change my position and make the same function call, you can see the actual values may change, but the difference doesn't. Then let's say we have the sine of 30 degrees. And this gives us, as expected, 1/2. Now the sine of 45 gives us 0.008. And what we would usually expect is 0.7. So this is a bit with a little bit of an issue with the rounding. So the last digit may be off by 1 in either direction. So keep that also in mind. Then the sine of 60 is 0.866 as expected. And then the sine of 90 is 1, again as expected. And with that, we've reached the end of this episode about reusing existing gear mechanics. I hope you enjoyed this episode. I wish you a nice day, and well, see you.